Everything you need to know about chemistry in 5 minutes. I'm not actually sure if we can hold up to that promise. Actually, it's pretty hard to fit a lot of all this chemistry in 5 minutes. Chemistry is the study of what makes everything. Mass is the measure of amount of matter. Atoms are what make up matter, and they are made up of protons, neutrons, and electrons. Now, protons are subatomic particles that carry a positive charge equal to that of an electron, but positive. Electrons are negative. Neutrons are subatomic particles that are kind of boring and don't have any charge, but can be found in every atom except hydrogen. Wowee! Change of state is, contrary to popular belief, not when you go on a trip to New York. It's when you go from a solid to a liquid, or liquid to a gas, or anything like that. A chemical change is when the makeup of the molecules change. You can tell that it's changed when bubbles form, colors change, or temperature changes. Or, crazy shit happens in general. When it changes, it's called a chemical reaction. A chemical reaction happens when there's chemical changes. Got it? Cool! Now, an element is an atom that always has the same number of protons. Electrons can come and go because electrons ain't a ship, a hose and trick. But protons always stay the same in an element. Now, a compound is when two elements get together and they say, hey, compound. Then they become a molecule. And they love each other. Gases are when the atoms are far apart and have weak bonds. Liquids are when the atoms are close together but still have weak bonds, so they just keep tumbling around the top of each other. And solids are when they're close and tight together and they can't move. Now, groups on the periodic table are when the elements are on top of each other on the table and have the same number of valence electrons. That means the same number of electrons in their outermost circle, and therefore have very similar chemical properties. For example, alkali metals, don't put them in water. And also don't confuse them with alkali earth metals because they're right next to each other. That's pretty fucked. Also, families are literally groups. The exam is literally just being a pain in my ass. Metals are this entire side of the periodic table. They're really messed up. They don't follow the rules of the rest of the table for electrons in the middle bit, and are typically hard, malleable, ductile, fusible, and good at sparking electricity. Metalloids are basically wannabe metals. They live under the stairs of the periodic table beneath the non-metals that aren't metals at all. But metalloids are basically just knockoff versions of metals that can't really conduct electricity very well. Moving on to chapter 2. Accuracy is how close you were to being right, and precise is how close your experimental results were together. And you can measure exactly how wrong you are in the international SI units. That's grams, kilograms, milliliters, all that. Basically used by all the smart people except America. Significant figures is possibly the dumbest part of chemistry. It's the numbers that supposedly actually matter. So, for example, if I got a measurement of 452.2 grams, but I was told to write it with only two significant figures, I would write it 450, 450. Any zeros before or after the numbers are not important, unless they're after the period. For example, 450.00 would have 5 significant figures, whereas 00450 would have 2. Alright, so proportions basically say that the number of elemental atoms from the start of a reaction will be the same as at the end of the reaction. It's conservation of mass. I really don't understand why they're making it complex and calling it something called proportions. It's a real pain, but you gotta do what you gotta do. Onwards, percent error. It turns out scientists have found out new ways to make you feel bad about how dumb you are. So they invented something called percent error to find exactly how off the mark you are, or as you might say, how inaccurate you are. To calculate percent error, you take the accepted value from the value you got, and then you divide by the accepted amount, and it gives you gives you a percent how much you were off by. Pretty good. Laws of conservation of mass and energy. Now, we've actually been over this, as you may recall, when we covered proportions, but I just want to cover this again to show how much of a pain in the ass this test is. You can't create or destroy mass, and you can't create or destroy energy. It's the law of proportions. It's the same thing. Time for a brief history lesson in the middle of chemistry. Yeah, that's right. You can't escape it. John Dalton was the guy who proposed a scientific theory for atoms and provided a baseline for what we use today. And he kind of based the ideas off of what the Greeks knew. And then some guy named Rutherford came along and basically proved what Dalton already knew using a beam of positive particles onto a metal foil. I mean, I don't know how that worked, but I guess it did. And yeah, that's basically all you need to know about the history of chemistry. An atomic mass unit is how we measure the mass of atoms. 1 proton or 1 neutron equals 1 atomic mass unit. This can be used in calculations later. The average atomic mass is shown on the periodic table right here underneath the letter. And it's how many protons and neutrons are usually in an element. Carbon, for example, weighs 12 AMUs. An isotope, however, is a molecule that has the same number of protons with a different number of neutrons. And that means that it has a different AMU. So it's not always, it doesn't always have the right AMU unit. You got that all right. Now, you remember how I said that we'd use the atomic mass earlier and later in calculations? Well, here's the time. It's something called the molar mass. It's how many grams there are per mole of substance. So, for example, with carbon, there's 12 AMUs, and that means that there are 12 grams per mole. Okay, and moles are it's a lot of atoms, alright? Yeah. In fact, this was such a big number that someone had to dedicate his entire life to finding out the exact number, and it was so big that he spent his entire life counting that number, and so they named it after him, and it was called Avogadro's number. 6.02 times 10 to the 23rd. That's a lot of zeros. Damn. Next up, we have light. I mean, shit, I don't know. It moves really fast. It's kind of warm. It makes you sunburn. Electromagnetic spectrum. It's a spectrum of light going from low frequency to high frequency. On one end, you can use it to talk long distances, and on the other end, it melts your flesh. And right in the middle is what we use to see. Whoa! Frequency and wavelength are basically the same thing. Wavelength is the distance between waves of light, and frequency is the time between the waves. A low wavelength makes a high frequency, and a high wavelength makes a low frequency. And this is the point where it's midnight and everyone who I'm making this video for is actually already gone to sleep and is not going to get to see it in time to actually know or care about it. So I'm just going to give up right now and call it review of the first half-ish of the year, kind of in 5 almost minutes. Thanks.